Okay. All right, so let's go through some example problems now.
Did I do that during time today?
When do you have line?
Today.
You either take the test in lab or the lab itself.
Okay, we'll take the test. I'll take the test.
Okay, today?
Today.
Okay.
Cool. Do I need to take a paper from you during, do I need to take a paper from you during lab time today or?
Yeah, I mean, then you do lab.
Okay. Okay, yeah. And that lab is a part of the test.
No, the lab is part of, no,
Okay, so I understand. Okay. Sorry, it's a little confusing. Sounds like
they're different. Okay, so these are some example problems. And for sure you'll see something like this on your real test. Now, again, I want to emphasize my practice tests are very similar to the real test. If you remember test one, practice test and test one were very similar. Okay, so we got 3.45 moles of water. And we need to go to grams. So using the molar mass, which is grams per mole, we can get that. So water is 2 H's, 1 oxygen, so that's 2O2, 16. Okay, so we put the grams on the top, so the moles cancel. And we're there. And we're looking at 3 sig figs. Now, there's also a key already done for you online. Some of you are having trouble finding it, and I had a number of messages from you. Did anyone not find it? Still can't find it. It's under Files Test Related. And if you click on creation date, it'll be at the top. And it's right next to the blank one. They're right together. The title differs. One says key, one doesn't. But it's the same one. Okay, how many molecules of water are there in 3.4 times 10 to the third grams of water? So we're starting with grams of water as the given. We want to find out how many molecules, how many? That's Avogadro's number, 602 times 10 to the 23rd. Okay, but that's a molar relationship, so we need to get to moles first. Okay, that gives us moles. Now we're going to go to number of particles. So moles cancel. So again, you're gonna use 602 times 10 to the 23rd atoms or molecules per mole, whenever I ask how many. Okay, so connect those two together. Okay, how many liters of gaseous water at STP are there in 8.27 times 10 to the 29th molecules of water? Well, given is 827. Hmm, Thank you. Okay, so we need to get to moles, and then from moles, we can get to liters. Okay, so those are three example problems. And you're gonna get approximately the same amount, 3 or 4 problems like that. Very similar. Grams, moles, liters, number of molecules. Okay? All right. Balance. Okay, so we've got 6 carbon on the left, 6 carbons on the right. 14 hydrogens on the left. 14 on the right. Oxygens, we've got 7 and 12 is 19. And we've got 2 on the left. So we're gonna have a fraction 19/2. Nineteen over 2 times 2 is 19. Okay, so it's balanced. Are we gonna leave it this way? No, why not?
How did you get that?
We needed 19 oxygens and they come by twos. Yes. So how do you get 19 oxygens from if they come in pairs? Huh? Yep. Exactly. All right. The reason why we can't leave it this way is you can't have a fraction as a coefficient. So to get rid of the fraction, we're going to multiply everything by 2. So we're going to put a 2 here. 2 times 19/2 is 19. This becomes 14. This becomes 12. So this is 12. 12. 28 hydrogens. 28 hydrogens. 38 oxygens, 19 times 2. And 14 and 24 is 38. So now it's balanced. And remember, assume all equations are unbalanced. All equations, regardless, whether we're working at single replacement, double replacement, always check. So what's the purpose of balancing an equation? There are two reasons you balance the equation. Okay, it's a molar relationship. Again, everything in chemistry is moles, 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 moles. So it's a molar relationship between reactants and products. Secondly, remember the word mole comes from molecule. So it's also a molecular relationship. And we're talking about two molecules of hexane plus 19 molecules of O2 will give you 14 molecules of water and 12 molecules of carbon dioxide. So molecules and mole frequently are interchangeable. Not grams. It's not a gram relationship. If it's in grams, you got to convert it to grams. I mean, convert it to moles. Okay? Okay, naming. Name or write the formula for the following. What's the formula for tri-oxygen monohydride? Now, I'm giving you a common ion chart. I'm giving you a reactivity chart. I'm giving you a solubility chart in the back of the test. Okay, so you don't have to worry about using your own or anything like that. Okay, so we need 3 oxygens and 1 hydrogen. So that would be the formula for tri-oxygen monohydride. Okay. Given the formula, copper phosphate, what's the name? Okay, if you look on your common ion chart, copper comes in 2 flavors, copper 1, copper 2. Copper 1 is a charge of +1, copper 2 is a charge of +2. So what's the charge on PO4, phosphate? It's on the far right. Negative what? 3. And we have 2 of them. So that's -6. So 3 coppers need to be equal to -6. So what's the charge on each copper? 2 times 3 is, yeah. 2, yes. Be +2 though. So the name is copper 2 phosphate. It's also cupric phosphate. Your next chemistry class is not going to do the cupric or cuprous, probably. You're going to be using the copper 2.
Are both answers.
Yep. Yeah. Next, I used to say, what are the two names for this? Oh, yeah, like in the pharmacy, they would use Cooper or Keypress, right? They wouldn't use copper too. Have you ever even seen that?
Because that is a compounding pharmacy kind of thing.
Right.
Now in the specific compounding licenses. And I think there's only one pharmacy in the area.
Are there more in Sacramento?
I think there's one in.
Wow.
Yes, yeah.
I used to go to a compounding pharmacy up in Washington regularly, actually. When I used to order for what I needed was, I guess, had to be made on the spot. No. Huh?
Special licensing.
That's why we live in a good state, though. Everything is nice, crystal pure, air is nice and clean. Just because we regulate the heck out of everything. But we reap the benefits as well. Kind of a give and take. Okay, any questions about naming? So you'll have one question on naming. And one will be ionic, one will be molecular or covalent. Okay, so this is a stoichiometry problem. Iron is made in a blast furnace using the following reaction. So, interestingly, they get iron from rust. Fe2O3 is rust. Okay, so is it balanced? No. We've got to check it, but it's not balanced. Okay, so let me balance it real quickly. And let's see it. Okay. Now let's balance that. All right, so if we start with 234 grams of carbon monoxide, how many grams of iron metal are we going to get? So we're starting with 234 grams. Now, the stoichiometry problem. First step is balance the equation. We've done that. Okay, so we're starting with carbon monoxide, CO. We want to end with iron, metal. So first thing is convert carbon monoxide to moles. So what's the molar mass for carbon monoxide? Okay, copper is 1201, oxygen 16. The reason why I know these is because I'm doing this for 50 years. Okay, now we're in moles. Now we need to go from moles of CO to moles of iron. So moles of CO needs to be in the bottom to cancel. Iron needs to be on top. Okay, so the 2 and the 3 come from the balanced equation coefficients. Okay, so I don't know what iron weighs. What is that?
55.
Okay, 55. You said 185? 85. Like that? Did you do the key or the practice one? All right, so moles cancel. CO cancels. We're left with grams of iron. How many sig figs should the answer have? 4. And you'll have one of those in the test as well. Now, the take-home problem that I was going to give you, we didn't have enough time to cover it in the lecture. It was a limiting reactant. And what it was, I was going to give you 2 givens, not 1. And it's quite a bit more work when that happens. But we didn't go over it in a lecture, so I didn't include it. So once again, you didn't have a take-home problem, but you did have the extra credit stuff. Okay, with the following chemical equation, right? Balance, right, both the molecular and anionic, if there is one, and spectator ions, if they exist. Okay, so this is a salt. And this is a salt. So when you have 2 salts together in water, when you mix them together, that's a double replacement reaction. So let's see what happens when we mix it up. Okay, so the lead goes to the chloride, the sodium goes to the cobalt. So we've got lead chloride. And if you look on your reactivity chart, lead is +2, chlorine is -1. So we need 2 chlorines to balance the +2 lead. And we don't know if that's a solid or not a solid yet. And then the other combination is going to be sodium cobalt. And the charge on that is -2. Okay, so look on your let's see, take out your solubility table. On your solubility table, find lead and chlorine, bring them together. What color is the block? Black or white? It's got to be one of the two. Unless it has some asterisks in it, that means it's partially soluble. I'm not going to give you any partially soluble ones. Okay, so take the chloride and the lead, bring them together. What's the color of the bottle? Black. What does that mean? Insoluble or solid? Okay, so the lead chloride is solid, it's a white solid. What about the sodium carbonate? So find carbonate, which is towards the bottom, and sodium, which is the first column over. Is it white or black? White, so it's soluble. Okay, so this is solid. And this is aqueous. So that's the molecular equation, balanced. Now, sometimes you don't get a solid, all you get is nothing. Mix it together, nothing happens. So that, you still have the molecular equation, it's just that there's no net ionic equation. So the molecular is this. The net ionic is something did happen. We made lead chloride. Before we go on, is that equation balanced up there? No, it's not. To start with, we have two sodiums here, two sodiums there. We have two carbonates. Two carbonates. On the answer key, what did I change the PbCO3 to just plain CO3? On the public, oh, that's fine. It was just, I'm wondering, do you have the printout?
That's what I found.
Right, okay. Okay, so is it balanced? Okay, we got two carbonates, one PB, two NAs, two CLs, two CLs. Now this lead is PB plus 4. Okay, so that's the molecular equation. Make sure you have all the AQs and it's balanced. Okay, net ionic. Net means something happened. What happened was we formed a solid. So how do we make the solid? Well, the solid is PbCl2. What came together to get that? Okay, so that's the net. Oops. That's the net. And what are the spectator ions? Okay, we have sodium and we had cobalt. Those are the two spectator ions. Yeah. This is the solid here, right? How many chlorines are in the solid? 2. That's where I got the 2 from. Okay. Balance and explain whether the following equations will happen. Yeah. Over here on the far right.
What is the class of? It doesn't have to be just without it.
Yeah, so is that balanced the way I have it written? Okay, everyone, let's check to see if that equation's balanced. It may not be. Okay, so let's go PBs, CO3s, Na, and Cls. Okay, so we've got one PB on the left, one on the right, two CO3s on the left, two on the right, two NAs. How many NAs do I have on the right? 4. So it's not balanced. Okay, you've got to do inventory each time you try balancing the equation. So we got to fix the NAs. So over here, instead of having on the left 2 NAs, let's make it 4 NAs. Oops. Okay, that kicks the chlorines up to 4, and we have 4 chlorines now on the right. Two leads on both sides. Okay, now it's balanced. Okay, so balance and explain whether the following reactions will happen. Okay, so we have magnesium solid or metal. So that's a metal plus a salt. That means it's a single replacement reaction. Okay, that means the magnesium and the lead swap. So we end up with EB plus magnesium nitrate, aqueous. So the question is, does that happen? Well, we need a reactivity chart to determine that. We're looking at lead and magnesium. So is magnesium above lead? Okay, here's magnesium and lead. So is magnesium above lead? Yes. So the metal is above the lead. That means this will go. Why? Because the magnesium is above the lead. Yeah.
Not sure why.
You want? That's all I need. The real reason is magnesium is more oxidizable than lead is. That's why it's above it. But we didn't really go into that depth. We just said, which is higher. So that's all I expect. If you want to put the other, that's fine too. Okay, What are the two half reactions? Now remember, half reactions shows the electrons. So we had magnesium is one, lead is the other. Now the lead is +4. The magnesium is +2. Okay, so because we start on the left at net 0, so the right has to be 0 as well. Because carbonate CO3 is a -2. Yeah, so we need a +4 to balance the -4. So these are -2 apiece. And you have two of them, so that's -4. That makes, this has to be +4. Okay. So this is a net 0. So that means the left have to be net 0. So that means that's 4 electrons we need. Okay, so are there any questions about these guys? So you'll have one double, one single replacement, and then one where you have to show the half reactions. Yeah. Yes, if we were to finish that out. No, just show it. Yeah, to finish that out, we'd have to multiply everything by 2 on the top, was 4. Yeah. These are just the simple half reactions. Okay, so what does no cut mean with Democritus' explanation of the atom? So you need to go through the key scientists and what they provided until we get to the current model, quantum mechanic model. So remember, Democritus was the Greek guy, and he came up with a concept of no cut, means atomos, atomos in Greek. That's where the word atom comes from. Now, no cut means if you keep dividing the molecule up until it's no longer that molecule. We used an apple as an example, or an orange or something like that. If you cut the apple, keep cutting it, and all of a sudden it's no longer an apple. That's the atom Democritus was talking about. But go through all the scientists and think of one sentence per guy. Bohr, there's 2. Bohr came up with the planetary orbitals, plus the electron can jump from one orbital to the next. So Bohr has 2, not just 1. Everyone else is 1. Okay, so let's find these guys now on the periodic table. We have metals, nonmetals, metalloids. Okay, so the metalloids are kind of in the middle between this. And metalloids are half metals, half nonmetals. These are the nonmetals over here. And everything else are metals. A lot of people miss the metals because they don't include everything. Okay, then I also had you identify 4 groups, yeah. Frequently it's included, frequently it's not, because hydrogen can also be over here. So if we didn't include hydrogen, that would, if you include it, that's fine. If you don't include it, that's fine too. It's probably more technically a non-metal because it's not shiny, doesn't conduct electricity. It's malleable, it's not malleable. So, so under those, it's not a metal, but frequently people just say everything else are metals. Okay, we have 4 groups. We have the alkali metals, alkali earth metals, halogens, and noble gases. So you can bring highlighters if you want. Just to make sure that I understand your identification. Okay, and I think that's the last question. What?
Can you go back to the
Which ones?
periodic?
And that's pretty much the test. Yours is going to be about the same length, same type of questions. Yeah. If you have one that's bigger, that's fine. But when you, on the test though, is to circle everything. So use your periodic table, it's bigger and you can see it better for the molar masses. That's what you're talking about, right? Yeah, that's fine. Her point she was making was a valid point. If you can't read the periodic table I provide, you may use your own. If it's your own, cannot have, you know, the identifying areas on it. So it's got to be a clean one. Okay? Yeah,
The signal concept.
it's on Canvas. I'm also including it on your test as well. The back page. Definitely try it at home though, because it's tricky. Also on the extra credit problem, don't be afraid of big coefficients. When I say big, I'm talking about over 100. A lot of people, when they want to put 100 and whatever down, they say, this is too big. We've never had coefficient. It's okay. It's just got to balance. If it takes 150 of them, it takes 150 of them to balance. Now, and again, there's 2 ways to do this. Did I show you the matrix way? Okay, that's not, I put it on Canvas, so if you want to look that up. Using your matrices, the TIE ones. But expect this. Yeah, but it's extra credit though. And I included it, I included it on the last page of the test in case you didn't do it and wanted to do it. Okay, that's what I wanted to cover today. Are there any questions about? No, yeah. 10 points. So it's worth a wet lab. Also, speaking of wet labs, lab coat. Decorating your lab coat. Okay, that's due anytime between now and the end of the semester. Yeah, both. Yeah, I like to see them. And then we can talk about what you did. Have you already finished yours? So if you've done your poster already, you can bring it in if you like. We can talk about it. I can't keep it though, because I have no space. This is the space I have, this briefcase. So I'd have a problem keeping all your posters.